trig equations. Try and solve something like sine 2 sine x minus cosine x is equal to 4 minus x between 0 and 2 pi. The main method in the calculator is just have y1 as your first y input as one of the lines or the curves. That one. Have the second input in your calculator is this. The other thing needs to be two functions where they cross over. So what you'll end, and set your window. So the x-axis only goes from 0, the lower one, up to, I suppose, maybe around 7 if you're using radians. Might be a good idea because there isn't any values you care about. And what you'll get is two graphs. You'll get some sine, cosine combination graph and some line. And all you need to go is, okay, you'll have your x-axis here. You have something like this. You're looking to find these 3 points and just the x values. And use your calculator for that. Use the intersect button. And it might ask you for bounds to the left. So you try and find the first one. It'll ask you to guess. Press whatever, press enter. And you'll find the first one. Then move your bounds over to this area. Find the second one. And do the same for the third one. And you should get 3 x values. So when you do that on the calculator, yeah. Okay.
Wait, so what's the standard for the window?
So x max, x min would be 0, x max 7. So we're only going up to 2 pi, around 6.28. Does this thing already? Y max. Oh, you can find other in your paper. You can find some. There you go.
That's where they fall. Where is it? Which one is it? That. Three. Where is it? Wait.
Yeah, I might have to.
So it would check.
All right, did we get three answers? Three answers, okay. There is another way of doing it. You want to do method, that's method one. Method two, you do a quick rearrange. 2 sine x minus cosine x minus 4 plus x equal to 0 and combine it into one function. This will also have some sort of curve, but this time you'll be just looking for where it crosses equals 0. The same, it's just a rearrangement. Instead of intersection, just convert it in one and look at the roots of that equation where x equals 0. And it's the same thing, it's easier for you to find the roots. Maybe you will, maybe you won't. Okay, and that's it, basically. I'll ask you some questions on those in a minute, but I want to go through the non-calculator version as well, which is more difficult. Okay, that's the calculator one. The non-calculator method. You recognize this in the exam because it's going to be in paper 1. You won't have a calculator going into the exam. That's how you recognize it. And you recognize it if it's not in the exam by the fact that they're a lot simpler looking numbers and operations. So let's have a look. Cosine x is equal to minus root 3 over 2. This is a pretty simple example. For each of these, I'm going to solve for x between 0 and 2 pi. So one full rotation. All right. So I'm looking for some angles. What would I want to do here? What's my reference angle for what angle gives root 3 over 2? Which one? Pi over 6? You sure? I don't know who said it. Yes, you're right. That's why you need to know those reference angles. In general, cosine pi over 6 equals root 3 over 2. That's in general. In this case, of course, we've negative root 3 over 2. So we need to think about where that would sit in our unit circle. Back to this. Yeah, it's going to be here and here, isn't it? Because cosine related to the x-axis, we're both negative. So, like two angles. And it'll be here and here. This one and this one all the way around. So this one's going to be pi over 6 less than 180 degrees, or pi. That's, I think, pi over 6. You'd write x is equal. That's one option. So that's pi over 6 less than pi. If you want to do it like this, you can, and you get pi over 6. And you're going to get pi over 6 more than pi on the other side. It's going to be 7 pi over 6. And they're the two places. Very straightforward. Usually this will be the last line of the question, where you're actually trying to find the angle after you've done some manipulation. So we'll do now a couple of them that require some manipulation. The first one, 2 sine x minus a half is equal to 0. So you want to be left with something like this. Cosine x equals, this one you want to be left with sine x equals. So we do some manipulation, some rearranging, add 1 to both sides. You get 2 sine x is equal to 1. Divide by 2 both sides to get sine x is equal to a half. And now we've got a known angle. Sine x is a half, what's my reference angle there? Pi over 6 again. Oh. I know that. I know that for sure. And you can keep going back to your table. It's not an exam, but if it's in the exam, you're going to have to remember these. So pi over 6 is equal to a half. Does that mean my answer is pi over 6? Well, yeah. X is pi over 6. Is that my only answer? No. Where's the other one going to sit? If I look at my pi over 6 is here, and its buddy is going to be over here. Positive half is also going to be there, isn't it? That's going to be, well, it's pi over 6 less than pi, so that's pi over 6. There. The last one. Here. We can do this one quicker than me. Go for it. Tan x plus root 3 equals 0. All right, so we'll solve it again in red. That means tan x, if I subtract root 3 from both sides, equals to minus 2. And I need to think about what my value for x in general, tan x, tan of something equals root 3. And I'm trying to frantically remember which one it is. Pi over 3, isn't it? 3 in general equal to root 3. Okay. So this time we want to figure out where that is negative. Tan is where sine over cos have different signs. So that, I think that's that and that. It's going to be negative. So we're looking for pi over 3 in these two quadrants. So that'd be pi over 3 less than pi. Remember, that's 0 to pi. So this second quadrant answer is going to be pi take away pi over 3, which is 2 pi over 3. That's our first answer. Our second answer, negative in this quadrant because cosine is positive and sine is negative. And for this one, we do it, well, we don't do it off 0. We actually do it with 2 pi take away pi over 3. 2 pi in general is 6 pi over 3. So if I take away pi over 3 from that, I get 5 pi. Okay. Let's do some of these.